Did you end up setting the time 19.6 or 64?
I did 20. I used
20, yeah.
So yes, that's the difference.
This is part A and B.
Wait, was that FSU one last year?
Or it was just
Oh, look.
Yeah.
Similar to our last.
Yeah, that's what, yeah. That's what I thought. I was like, this is not what I like.
Part A and C.
I
Sounds like BF squared equals BI squared plus what is it? 2AD. Yeah, the velocity final squared.
Kinematics. So I literally still using kinematics.
Yeah, the velocity final squared is initial squared plus 2 acceleration times physics. So we know our final square is 0 and the rest initial square.
I haven't. Okay, good. For part B,
All right. Let me just talk about the calendar for a few minutes here. We have today we're covering differential equations. We're going to see that this is quite steps intensive. And the big idea with differential equations is we're just taking a derivative equation and taking the antiderivative to make it move up to the function level. But the complexity comes from the fact that we have to work on both sides of the equation. So we have to basically working two problems within the same equation. The left side is its own problem. The right side of the equation is its own problem. And then after that, there's also quite a bit of algebraic cleanup that's required. So we're going to go slow. We're going to take our time with this, but just understand that it's going to take some time to kind of get comfortable with it. There's quite a few different varieties. So, but right now, just want us to be able to feel like we can follow the step from one step to the next. Okay, if you can achieve that today, we'll take that and we'll just build on that over the next this next week. Tomorrow we're doing differential equation word problems. These really we're just going to be able to find the antiderivative just by the set of equations. So really not a whole lot of calculus tomorrow. Just have to be able to know how to insert into the equation. We have a lot of this is calculator heavy, so we'll make sure to bring your calculator tomorrow. I'll try to send out a reminder this afternoon. Monday we're going to go over slope fields. Slope fields seems kind of strange. It's kind of a relatively new topic that got included into the AP curriculum not too long ago, but we're really not going to have to create all these what you're going to see with slope fields. Really just have to know how to interpret them. We're going to spend multiple days just getting some more additional practice with solving differential equations. So I'm going to have that available for us to do. Thursday, we have our last lesson of the unit, which is inverse trig antiderivatives. We're taking all the derivative rules that we learned first semester with inverse trig and taking the antiderivatives of it. So a lot of it is use substitution as well. We have a long weekend coming up, and then 2 days of test review, and then chapter 5, 6 test. Not next Thursday, but the Thursday after next. Yes. I'm sorry. Oh, sorry. Yeah, the part 2. I'm still working on it. I'll probably won't be able to enter that in until the weekend. Yeah, and I'll try to enter those into the gradebook this weekend as well. Okay, that's going to lead us to so at the end of February we're going to start chapter 7, which is our last unit. We should be able to get done with chapter 7 by beginning to mid-March, and then we'll have the rest of March just to start reviewing for our AP exam. We're still going to have quiz and tests along the way, but we're going to try to put things together and have the tests and quizzes to be more AP format, so we can kind of be comfortable with what to expect come May. Okay, so we'll have March to do AP review, April to do AP review, but as you know, April there's a lot of things going on, and there's also spring break in April, so want to get a head start with AP review in March if possible. Okay, any questions with the calendar, with the schedule? Okay, let's go to page 1. Okay, so let's talk about this here. Separation of variables is the rearranging of equations with y and dy, which is our dependent variable, on the left side, and the x and dx on the right side of the equation. Again, differential equation just means that we are starting with equations at the derivative level, and then solving differential equations just means that we're going to take the antiderivative, which we already know how to do. It's just that the setup feels a little bit strange because now we have to work on both sides of the equation. Okay, so typically, whenever you see, right now we're just dealing with x's and y's. X's are always the independent variable, and y is always your dependent variable. Now, when we go to problems like that are more AP style, we're going to see different variables coming into play here. And if you see t and dt, just understand that your t and dt will be your independent variable. So if you see problems involving t and dt, just understand that, okay, treat that as your x, okay? And typically on the AP exam, it's more word problem-ish. And so time is involved to create the scenario, which means that your dependent variable could be just a strange variable. It could be like a p and dp, or it could be q, or it could be r, it could be w. So a lot of times students get thrown off by that, but just understand that if you see a strange variable, it's always going to be paired with time. And if you see time, just understand, okay, that's your x. Whatever the other variable that you see is your y. Okay. Okay, so first step for solving differential equation is we want to work towards separating the variables. So this is the first thing I like to do is I like to try to get the equation to be a fraction equal to a fraction. I may have to move things around in the future, but right now with an easier example, it's already set up this way. Okay, so this is the first step I like to take. I like to just cross multiply. Okay, and the reason that I do that is so that I can get everything up at the numerator level. Having everything up in the numerator level, it just feels easier. Denominator just feels a little bit just awkward and not as familiar. So we're going to bring everything up to the numerator level. Okay, so I'm going to say y dy is equal to 2x dx. And any chance that I can get that y already on the left side, it's just going to make things easier for us, or easier down the road. Okay, so cross multiply y dy equals 2x dx. Now, the important thing that I want you guys to notice whenever you cross multiply is that your dy and dx's are set. Those are in the right places automatically. Okay, it's important that your dy is on the left, that your dx is on the right, but more importantly is that your dy and dx's has to be sitting in the numerator. Okay, if they're not in the numerator, then something is not quite right. Okay, so we always want to make sure that those are your anchors. Those are your anchor variables. Okay, now having said that, that means that it's okay if algebraically your y's or x's end up in the denominator. That's fine. Okay, as long as they're separated and as long as your dy dx is in the numerator, that's what's important. But here in this case, looks like y's and x's, they both end up in the numerator. So we're just going to keep them the way they are. Okay, do we have full separation of variables here? Okay, are all the y's and dy's on the left? Yes. Are all the x's and dx's on the right? Yes. Okay, so we can move to finding the antiderivative. Okay, so now take the integral of both sides. And really, you got to be patient with these problems because really we're working with two independent problems. Okay, eventually they're going to merge, but right now we really need to treat these like two separate problems. Okay, what do we do on the left side? What's the integral of y dy? Yeah, just power rule, right? Power rule with the y variable, y squared over 2. Now technically there's also a what? Plus c. Good, but that plus c, we're just going to make it come out later. Okay, both sides will produce plus c's. We're just going to make the plus c come out once on the right side. Okay. All right, so that plus c is going to come later. Okay, 2x dx looks like this is also set up for power rule. what does that become? Just x squared, right? Okay, so I'm going to write down the full thing here. 2x squared over 2. We know the 2 will go away. Okay, so y squared over 2 is equal to x squared plus c. So right now, I just want to try to get that y squared by itself. All right. Eventually, we got to maybe solve for y, but right now, for the fact that we're making a general solution, getting the y squared by itself is good enough. What can I do to get y squared by itself? Good. Dividing by 1/2 is the same thing as multiplying by 2. Okay, distribute the 2 through. The 2's will cancel out with the first term. I'm just left with y squared. Equals 2x squared. I'm going to distribute to everything I see here plus 2c. Good, right? So I just want to show that technically we are distributing 2 to everything, but 2c is still a what? So a constant. So you don't have to write this step down. You can just understand that, okay, if I distribute anything to the c, it'll stay as c. You don't have to write that 2c. I just want to show that, yes, we did take care of that 2 to everything, but the c has a way of absorbing any constant that comes its way. Yeah. Yes. Question.
When solving the antiderivative for y dy, wouldn't there also be a plus c on that side?
Yes, there's also a plus c on the left side, but the plus c, we're just going to make it merge to the right side and just call it plus c on the right side. Okay. You may be thinking, wait, what if they cancel out? No, they're both different c values, so it may be 0, but 0 is also a constant, so we'll just let it handle all that constant, all the possible constants, just have it plus c on the right side. Okay, so this is what we call a general solution because we don't have any information to replace c with. Okay, any questions so far? All right, number 2. dy over dx equals x times 1 plus y. Okay, I see the possibility of creating a fraction out of the right side, so I'm going to put this over 1. And as soon as I can see a fraction equal to a fraction, I'm just going to cross multiply to get the denominators out of the way, and then to get the dx and dy set. Okay. Oh, something else I want to point out to you is normally if it's an integral problem, I would say, hey, if there's a set of parentheses, go ahead and distribute it through. But with differential equations, the parentheses are there to help you. Okay, so you want to keep the parentheses because the parentheses is there to kind of help you separate the variables that need to be separated. Okay, it's kind of giving you a head start into the separation of variables. So don't distribute the x through. If you do it, you're kind of taking a step back. Okay, so the parentheses are there to help you see things a little bit more clearly. It's not there to hamper your progress. Okay, so leave the parentheses there. We're going to cross multiply. Okay, I'm going to cross multiply in a way that will have my y's on the left side. So 1 dy is equal to x times 1 plus y dx. Okay, everybody comfortable with that step there? Okay, the thing I want you to notice is that the dy and dx's are set. Okay, do not move them. They are already where they should be. Okay, don't try to divide. These are already set. Now, look at the rest of the problem. Do we have full separation of variables? No. What's out of place? Good. But the y is with the 1, so if I want to move the y, I need to move the 1 along with it. So basically the parentheses has to move. But if I move the parentheses, where's it going to end up? Denominator. Okay, so I want to point that out. Okay. Denominator. So this is where I see some students wrestle with this a bit. I think the tendency is, at least from what I've seen in the past, students feel like they're doing something wrong if they see a variable in the denominator. Okay, so I want to just reassure you that it's okay to have your variable in the denominator because we have rules specifically that can handle denominator variables. So this is what I see some students do. They put it in a denominator and then they second guess themselves and they end up putting it to the numerator without making an adjustment. So all of a sudden it becomes 1 plus 1, 1 plus y dy, and they go through that process. So just make sure that you trust your algebraic steps. If it ends up in the denominator, that's where it's supposed to be, and you can move forward that way. Your dy dx's have to be in the numerator, but it's okay if your y's or x's land in the denominator. Okay, you're not at a dead end if that happens. Okay, let me rewrite the problem so I can get more clarity here. Typically, format-wise, I like to push the dy outside of my fraction. It just feels more familiar. Okay, take a look. Do I have full separation of variables? Yes. Okay. Okay, we have to treat each side like its own independent problem. So let's look at the left side here. Left side, we can't really expand, right? Too many terms in the denominator. We have to go through what? U substitution. What's the U value? 1 plus y, and this is just going to end up being a what rule? 1 over u, which is natural log, right? So if you feel comfortable, you can jump directly from here to the natural log rule if you don't want to go through U substitution, or if you feel like you see the result of U substitution. But if you want to go through U substitution, you're welcome to do that as well. It's just that for easier derivatives or easier U values, we could potentially skip that process if you don't want to do as much writing. Okay, so we know the result of this, just 1 over u, which is natural log. So we have natural log absolute value of 1 plus y. The plus c will get transferred over to the right side. We'll wait for that to happen. Any questions for the left side? Okay, the right side, what's the integral of x dx? What does x become? Yeah, power rule, right? So x squared over 2. Now we can have the plus c show up. Okay, any questions up to this point? So we've separated the variables, we've taken the integral, all the calculus is done. However, we still want to solve for y, okay? But you've earned the majority of the points up to this stage, okay? You've done all the calculus, you brought everything up, but we just have one more thing to do, is to get that y by itself, okay? So there's still quite a few algebraic steps ahead, but any questions up to this point? Now let's talk about this y here. The y is not easy to move because it's inside the natural log. I can't just subtract the natural log over. Okay, I have to deal with the natural log independently because it's the fact there's a y inside the natural log. So how can I get that? How can I release that y away from natural log? What can I involve to undo this natural log? Okay, I'm going to involve the inverse. Yeah, so the inverse function of natural log is e. So the way we're going to work e into this process is we're going to raise both sides with e as the base. Okay, because if I can involve e and natural log together, they can cancel out and I can drop the absolute value and I can have that y. I can one step closer towards solving for y. But anything I do to one side of the equation, I'm also having to do on the other side of the equation. I got to balance everything out. So now everything in black here is sitting in the exponent level. Okay. E and natural log will go away nicely. Keep the absolute value for now. I'm going to rewrite this right side here. Everything is now sitting at the exponent level above base e.
Even the C?
Even the c, yep. Even the c. Okay, any questions from here to here? Now, there's a very specific cleanup process we're going to do with this expression. Yes, question. Yeah.
What happened to x squared?
It's x squared over 2. Yeah, I ran out of room, so I made it a little bit shortened, but it's still x squared over 2. Good with that? Okay, so here's the property that we're going to apply to get this cleaned up the way that problem wants us to clean up. And it's this property here, this exponent property that says if I have a base raised to the sum of exponents, I can split that up into the product of bases. So a to the m plus n can be split up into a to the m times a to the n. Look at that change in operation here. A plus sign in the exponent is going to turn into a multiplication sign once the bases are split up. So look at, I'm going to recopy the left side here. How would you apply this property to this right side of this equation?
E to the x squared over 2 plus e to
Okay, careful. E to the x squared over 2, not plus, but
or times.
times. Okay, but I'm glad you said that plus because that is a very common thing to do that students make because they see a plus there, so why not bring a plus there? But just understand there's going to be a change in operation because a plus sign in the exponent is not the same as a plus sign below. A plus sign in the exponent is going to convert to a multiplication sign. Okay. Now, we're getting closer towards cleaning this up because I want us to explore what this means. What do you think? What do you know about this e to the c? Any idea here? What's E? E is a what? It's a constant. C is also a constant. What happens when we have a constant raised to a constant? Still a constant. So we can just replace this E to the C with just a big C. Does that make sense? Okay. E is not a variable. C is not a variable. These are both constants. If I have 2 raised to a number, I still have a number. But now, all of a sudden, it becomes a multiplication, which means that the C is really a coefficient. And typically, we have the coefficient sitting in front of the variable. So it transfers to look like this. Okay, does that process make sense? There's a lot of stuff going on here. So take your time and see, and let me know if you want me to clarify anything. Everybody good?
E to the c is just going to constant.
That's right. E to the c is a constant, but all of a sudden it's no longer plus c. It becomes a times c, and that's why we push it out in front. That's multiplication. Because we pushed it to the exponent, so to bring it down, it's going to turn into multiplication. Now, we have one more thing we got to take care of, and it's the absolute value. Okay, we know absolute value has a way of representing plus or minus, so we're going to drop the absolute value, and as we drop the absolute value, it's going to transfer over to the right side as a plus or minus ce to the x squared over 2. Okay, because we made that balance, right? We want to solve for y. We want to remove that absolute value. The absolute value goes away, plus or minus. But what do you know about c here? C is a constant, so that means c can be both positive and negative. So the plus or minus would just get sucked into that c. We don't need to have that plus or minus, but I just want to show you that we are taking care of that absolute value, but c just ends up taking it all in. Okay, we're almost there. Yeah, -1. Okay, so now final step, we can get that y by itself by just subtracting the 1 over to the right side. This is our general solution. Right, a lot of steps here. We're gonna get a lot of time to practice, but right now, let me know, is there a step that you're stuck in terms of one to the next?
We get points taken off if we keep the plus minus c.
No.
Wait, what?
Would you get points off if you have the plus or minus c? No, but it's just cleaner to just leave it as c, because c will just take in all the plus or minus values. Yeah. Right, right. And the reason why is because e is a number, right? It's like 2.7. 2.7 raised to a number is still a number. So we can just clean that up and say, well, if e to the c is a constant, I'm just going to call it a big C to make this a little cleaner. Okay. That's right. And then the plus or minus will just get absorbed into C. So if you jump from this step to this step, I'm okay. I just wanted you to be convinced that the absolute value is taken care of. That even though we drop it, it is being it's being balanced out with that C. That C is taking that balancing act from the left side. Yeah.
So if we just leave out the plus or minus step, like that's all right?
That's fine. Yeah, you can go from here to here to here. You can. I just want to show you that we are actively taking care of that absolute value. That we're not just dropping it randomly. That we are doing something active on the right side as well. Some students have asked about, wait, that 1 is a constant, so why can't I just make that 1 go into the C? So these are different operations here. If this was plus C and there was a minus 1, then I can make that 1 go into that C. But that C is being multiplied, so it's not quite apples to apples. We can't just make that 1 merge into that C. It's not being added to this variable. So this is multiplication, this is addition, so we need to keep them separated. So we need that minus 1 there. Okay, good. Any questions so far? All right, number 3, find a general solution for 2x plus 3y, y prime equals 0. So general solution just means that we want to get the equation down to a point where a c is involved. And then we're going to find the particular solution. So particular solution just means that we take a general solution, take the order pair, solve for, replace the x and y with the order pair, solve for c, and then update the general equation with the new c value. Okay, so let's look at number 3 here. I do want to talk about how to set this up here. Whenever you see y prime is a shorthand way of writing dy dx. But we want dy dx in our problem because it kind of helps set our problems, set the parts that need to be in place. So whenever you see y prime, rewrite y prime as dy dx. Okay, so take your time with this. We're not going to be able to get full separation on the first step, but ideally, I want to get it so that I can at least get just one fraction equal to another fraction. Right, I want to be able to get this scenario so I can cross multiply. So what do you think I could do with my first step?
Subtract 2.
Yeah, if I can subtract 2x, I can kind of work towards that fraction equaling to a fraction. And then I can cross multiply. If I can cross multiply, I'm on my way to working out my problem. Okay, so I subtracted 2x. I made the fraction, the numerator and denominator, a little bit more clear. Again, I like to take this step, this cross multiplying step, just gets the dy and dx's locked into their spots. Okay, any questions up to this point? Okay, cross multiply. Okay, 3y dy equals negative 2x dx. Look at dy dx, that should always be in the numerator, okay? Make sure that those are always in the right spots. Looks like the y's and x's also end up in the numerator, so if that's where they're supposed to be, then that's fine. Okay, take a look at our problem here. Do we have full separation of variables? Yes, we do. X's on the right, y's on the left. Now I do want to have an additional step for you to consider. It's the fact that we're trying to solve for y in the end. So any time that we can leave the left side as bare and as minimal as possible, that will just help things down the road. So it's not wrong if we go into our antiderivative step, but typically I like to encourage students to just, if it's possible to move anything from the left side to the right side, go ahead and do that now. Is there anything that does not have to be on the left side that we can move? That 3. We can divide that 3 over. Okay, sometimes you can't move a number like this one, right? The 1 here, we can't just move that 1. That 1 is stuck. So this has to stay where it is. But here, if something can be moved, I typically like to just go ahead and move it, right? Eventually, it's going to have to be on the right side. So any small step that we can take, it'll just make our process a little easier down the road. Okay, so y dy equals negative 2/3 x dx. Okay, take the integral of both sides. Now that I have full separation of variables. Okay, what's the integral of y? There's a plus c, but we're waiting for the plus c to show up. Okay, negative 2/3 x becomes good. I'm going to take it one step at a time, but you're right. Do some cleanup here. The negative 2's can cancel out. I'm just going to make it negative 1/3. Okay, good so far? Okay, right now we just want to target the general solution. So what else can I move? 2. Dividing by 2 is the same thing as multiplying. Sorry, dividing by 1/2 is the same thing as multiplying by 2. Distribute the 2 through. So y squared equals negative 2/3 x squared plus c. This, we can finish part A and call this the general solution. Any questions with part A? Yeah. Yes, it would be 2c, but what do you know about 2c? Still constant, so we can just let that 2 get sucked into that c and just write it as plus c.
So does general mean that you don't square the like
General just means that there's a c that is in our equation. And then when we move to particular solution, we're going to update the c value up to a number. Yeah, we can leave it like this. It's asking for just a general solution. It's not asking for a function, which is okay. But for part B, it says find a particular solution as y equals f of x. So here we do want to solve for y. We're going to, when we get down to part B, we're going to involve the square root because we are going to ask for a function for part B. Okay, so now part B, we're going to find the function y equals f of x, and we have the help of an ordered pair, 1, negative 2. Okay, so we're just going to insert 1 and negative 2 in for x and y and see if we can use that information to solve for c. Okay, add 2/3 to both sides. Common denominator. So now that you have your updated c value, or now that you have your c value, you're going to update the general solution and convert your general solution and move towards a specific solution. But like we said, we're still not quite there yet because we're going to be asking for a function, so y squared is not yet complete. Okay, everybody good from here to here? We've updated the c value. Okay, so now it's asking for find y, right? So now we're going to involve a square root, so square roots. Now, anytime you take the square root of an equation, what has to show up outside? plus or minus. Now, plus or minus indicates that there are two separate functions here. So we have y is equal to positive square root and then a negative square root. However, only one of these we can keep because it's asking for a solution that passes through the point 1, negative 2. So we want to pick the branch that includes this point. Okay. So in other words, we want to be able to insert 1 into the function and see which one produces a negative 2. A quick way to decide between the two is look at the y value. Okay. Whatever the sign of the y value is going to match with the sign of the square root that we want. We have a negative 2. The only way we're going to get a negative 2 if we insert 1 is if there's already a negative sitting outside the square root. So if you're ever having to choose between two functions because you have plus or minus radical, look at the y value of your ordered pair. The sign of the y value of ordered pair is a sign that you want to match to choose your solution. Okay, questions? Okay, 2 more examples. Page 2, number 4. Okay, does anybody still need this? The reason why is because the direction says choose a solution that passes through the point. So the point is only going to go through one of these functions. So the way that we can tell, you look at the y value. Whatever the sign of the y value is, it's going to match the sign that the function has to be in. Okay. All right, so here's page 2. Okay, find the general solution for y prime equals 6 cosine pi x. First thing we do is let's get that y prime to be more descriptive for us. So we're going to rewrite that y prime as what? dy dx. Yeah, dy over dx. Okay. I'm going to rewrite this in a way that I can get it to look like a fraction equaling to a fraction, so I can cross multiply. I may not get full separation, but I will get the dy and dx's in their right spots. Okay, let's take a look at what we have so far. Dy, dx's, those are good. Those are in their right places. Okay, do we have full separation of variables? Yes. Is the left side as bare and as minimal as we can get it? Yes, okay. There's nothing that we can move from the left to the right side. X's are on the right, Y's on the left. We're ready to take the integral of both sides. Again, these are independent problems, so you really need to treat these like 2 separate problems here. Let's look at the left side here. What does 1 dy turn into? Okay, y squared over 2. We'll save the plus c for later. Okay, what's the integral of cosine? Sine, positive sign. It's opposite, right? Integral is opposite. So cosine is positive sign. Now, there's a little bit of what going on here? We got to keep track of the what? Yeah, this is a little bit of what? U substitution, right? U substitution. Now, we don't go through the full writing out the U substitution if we understand what's going to come out of it. What's going to come out of this pi x? That's what happens with U substitution, though. Okay, but what happens with that pi? Is it times pi? Okay, okay. But this is not quite chain rule, right? If it was chain rule for derivatives, we would just say you know, cosine becomes negative sine pi x times pi. But what happens if we're doing u substitution? There's the reciprocal. It's the reciprocal of the derivative. Okay. Now, if you're not comfortable with that shortcut, let's go through the full. I don't want you to jump a step if it's not comfortable with you. But typically, if I see a linear function, I just know that, okay, I know there's a leftover, but it's the opposite of chain rule. So whatever the derivative is, I just got to make sure I flip it. So it'll be 1 over pi. But let me show you the full step here. You see that pi is going to show up, but it's going to show up in the denominator. So if you're comfortable with that step, just know that, okay, cosine becomes sine, pi x will produce a pi, but in the denominator because it's going to be a reciprocal. Okay, I just want to create opportunities if you feel like you want to do some shortcuts for certain parts of the problem, but don't do it if you, oops, sorry. Don't do it if it feels like it's too much to do in your head. So you can write everything out if you want. Okay, we know cosine becomes sine. And then replace the u back in terms of pi x. But just understand that anytime your parentheses has more than an x, you gotta remember that there's a coefficient and there's always going to be a leftover. In this case, it's going to end up in the denominator. It's always the reciprocal of the derivative. Okay, we're almost at the general solution spot. What can I do to get it to that y squared by itself? Okay, multiply both sides by 2. Okay, so here's my general solution. Okay, I'll box this off and call this general solution. Okay, so now part B, I want to get to the particular solution. In this case, it says solve for y. So we are going to have to involve the square root. But first things first, let's get that. Let's solve for c first, right? So replace x and y with 1 and 2. And let's solve for c. Pi times 1 is just pi. Okay, this looks messy on the right side here, but what do you know about sine of pi? 0. So that 0 is just going to take the whole thing with it, right? So what's c equal to? 4. Update your general solution, and we're one step closer towards solving for y and the c being replaced. Okay, so I'm going to take that 4 and update it into that c. Okay, rewrite your equation. Okay, we're almost there. What's our final step, or what's our square root? Okay, what happens with the square root though? Plus or minus, okay? So though we have to decide between 2 potential solutions, and we can only choose one. Okay, which one do we choose?
Positive.
Yep, the y value is positive. The only way I can plug 1 in and get a positive in return. Okay, y is positive. I choose the positive square root. I do want to point something out here. Some of us may look at this thinking that we can continue cleaning up, but why can't I just make that square root of 4 2? Why can I not do that? Yeah, it's being added. So just understand that when things are being added or subtracted, is not as clean as you would like for things to be. We can't do a lot of things when that we would like when terms are connected by addition or subtraction. So this is basically as clean as we need to get it. Okay. Yes.
Going back to like finding the C, how do you cross out the pi? The sine of pi?
Right, because sine of pi is equal to 0. So 0 times 12 over pi is still 0, so I can make that whole thing go away. Okay, good. All right, any other questions here? Okay, one last one here, number 5, okay? Okay, y prime equals x plus 1 times y. What's the first thing we can do? Okay, dy dx. Again, parentheses are there to help you. Don't lose the parentheses. It's already kind of separating some things for us, so don't lose the parentheses. Okay, I'm forcing that 1 in the denominator. I can get a fraction equaling to a fraction. Let's cross multiply. We can get some things, we can make some progress just by doing that. Okay, dy dx's are in the numerator. They're in the right spots. That's a good sign. Good. So we don't have full separation of variables, right? So there is something out of place, and it's the y. So how can we move that y? Divide it, okay? When you divide by y, where does it end up? In the denominator. And it's okay to have variables in the denominator, okay? I think this is what I see. A lot of students, they second guess themselves. They say, oh, that y looks out of place. And they rewrite this problem as y dy, and then that just throws off their whole problem, okay? It's okay to have y's or x's in the denominator. If that's where it ends up, that's where it ends up, because we have a rule that can handle those situations. Okay, now we have full separation. The left side is as bare and minimal as we can make it. Now I can drop the parentheses, okay? Because the x's are by itself. There's nothing connected to it. Okay, left side first, right? There's no need for u substitution. This is the same thing as 1 over u du, but just in terms of y. We'll save the c for the right side. X is its own rule. 1 is its own rule. What does x become? 1 becomes good, x, okay, plus c. Okay, you've earned the majority of the points because you found the antiderivative, you got the plus c to show up, but we have one final step, and that is to solve for y. Y is stuck inside the natural log. That's involved e. Raise both sides, e is the base. The left side cleans up to be just what? Okay. Right now, to keep the absolute value, we are going to eventually deal with it. Now, the right side, okay, we're going to apply this rule here. A to the m plus n can be expanded into a to the m times a to the n. Now, there's three terms. However, the important thing is we just want to separate the constant away from the variables. So it's okay for us to keep this together. We just really want that c to be its own thing. So I'm going to rewrite this as e to the x squared over 2 plus x. What's next?
CE to all.
Okay, times, right? Good. So make sure there's a common mistake. A lot of students want to carry that plus sign down, but it becomes a multiplication. And now that this e to the c is by itself, we can call it what? Just c. And we can push it in front as a multiplication coefficient. Along the way, we can also drop the absolute value, plus or minus, and that c will also absorb the plus or minus. So all we have left is just ce to the x squared over 2 plus x. Okay, it's a lot going on, but I'm glad that you guys are actively following and asking questions and taking each step. Okay. Okay, we'll get a lot more practice with this, but I think that's a good start for today. You guys have some homework. bring your calculators tomorrow. We'll have a lot more time to practice the problems, but hopefully you guys are able to follow these steps.